For this problem, I have a wall and then a bar out of the wall, tension pulling up on the bar, and a sign hanging from the bar weighing 200 newtons. Angle here is 30 degrees. And then they want me to find the tension of this cord pulling on the bar. But first, I should draw a free body diagram of the bar. So this is the bar, and then for the forces, I have tension pulling up on the bar. I have the gravitational force pulling down on the bar, and these are all vectors. And then the wall is pushed. There's a normal force of the wall pushing out on the bar. And since the bar is not moving, we should say this is at equilibrium. We could say it's at equilibrium. Therefore, the sum of all net forces, you got mg plus tension plus the normal force. And then to find the tension, you have to find x components and the y components. I will draw my axis here. This is my y-axis, x-axis. And then I would find the sum of all x components. Sum of all x components, x direction, positive, I have n, plus, this is 30 degrees. And then x right here is adjacent from the angle of the tension, so therefore it's cosine of 30 degrees, and that's your that's the y components. And then the sum of that's the x component. Now we're doing the sum of the y components. We have tension going up, which is positive, and this time it's opposite, so sine of 30 degrees. And then the gravitational force going down, negative mg. Now to solve for tension, you can do, for the x, you can do t minus n to the other side, negative, and then this was going to the negative x direction, so that would be negative, and then divided by negative cosine of 30, which gives me positive n over cosine 30 degrees. And then for the y components, solve for t, I would have t equals minus m, since it's negative, add mg to the other side, and then divide sine of 30. Since I do not know the normal force, but I do know the weight that is pulling down on the bar, I will use this one. So I would have tension equals the weight of the sine divided by sine of 30 degrees. Sine of 30 is 0.5, so 200 divided by 0.5. So this cord right here will have the tension of 400 newtons. And that's the answer.